Okay, so exporting normal maps and displacement maps out of ZBrush to put them into Maya for use with the Renderman 21. So I've got this elk donkey-like character that I sculpted several years ago. I use this as my example. So I've already created a UV map for this using the UV master and basic setup. What I want to do is just make sure I cover the basics of the normal map and in particular the vector displacement map for this process. So I'm going to go to normal map. I'm not going to do it up here in the multi-mapper, just do them individually. So you can see my settings: tangent, smooth UVs, smooth normals. We need to turn this down to 1 as our base normal map, and we will go ahead and create a normal map. Calculate, calculate, calculate. Okay, so I have myself a UV map. I will clone that and up to texture. And the one thing about this is I know the UV map is actually at the bottom instead of the top up here. So we will go ahead and flip and export. And I'm not going to do it because I've already done it, but this would be the normal map. So I've saved this in my little capture area there. All right, so that's 1. Let's go back up to geometry. Turn that back up to 6 and masking. So I've already done this, but I went and created a cavity mask, or so basically on these little depressions. I want to try to use something where I can mask out reflection details, little indentations. You know, when you're using a normal map, you're not really distorting the surface, you're giving the impression of that. You can also do this with, you know, some kind of map, a black and white map that's breaking up the reflections and things like that. So I already went and did this. I turned the intensity all the way up to 80, blur 80, and if we go ahead and view that mask, there it is. And I can, once that's created, I could go ahead and say create alpha, and that will jam it over here. And make sure that's selected, and then with it selected, I need to flip it, though it's not going to let it flip it there. So I have to do that in Photoshop, but I'll do that later. And I'll flip that over. And again, I guess maybe what I could do is, let's go back up here. Multiple map exporter. There's my cavity map. Let's make the intensity, what did I have, 80, 80. And hopefully it will do the flipping correctly for me. 16-bit, and I have the map border at 2. And I'm missing one thing in here somewhere. I guess I have it all. So we'll go ahead and try that. Create all maps. Let's just see if that does it the right way. Oh yeah, it probably did. There it was. I was looking for it. I had it already turned on. There it is, 18 seconds. Okay, so in using the multi-map exporter, I told it to flip these right there. So I'll get that in the right direction. So that looks good to me. And we'll turn that mask off. That's 2. Now the third one, this is the important one. If you haven't been paying attention, pay attention to this part. So back in the day when we did displacement, it was usually just a scalar value. So it was black and white, and that would tell the surface how much to indent or push away from the base geometry when it did its displacement of the micropolys that it created at render time. Nowadays we have fancy color maps that indicate vector. So instead of just moving perpendicular from the surface, you can get overhangs and things like that. Don't ask me to explain it, go check out the documentation. So we're going to create a vector map. We're just going to turn on all the options here for the tangent, 32-bit, smoothing the UVs and the normals. So that's all good. But this is the most important part. So preferences, and let's see, is it here? Yes, it is. Okay, so in the import exporter, there is this tangent, flip, and switch. Crazy name, right? So there are 48 of these. Why are there 48? I actually don't know, other than maybe all the different programs or different variations. But as it turns out, so arbitrary, of the 48, 43 is the one that Renderman likes to use as far as the color set. So if you want to get this correct, you have to go into Preferences, Import Expert, and choose 43. Again, only by drilling down in the documentation will you find this. And then you can come over here and create that map. I've already done that, so I'm not going to do that again. It will also at the same time ask you if you would like to export the geometry for that, right? So I'm not going to do that, but those are the three things. So normal maps, that you should have a understanding how to do that. Don't forget to do cavity masks and things like that. You can get lots of little detail. We can use that in interesting ways. There's a mask or diffuse gain or whatever, reflection amount. And then the vector displacement is what we're going to use here, right? So I'm going to pause right there, and then I'm going to shift over to Maya and come back and see you in a minute. Okay, so we're back here in Maya. I have the basic geometry set up and just a simple render. So just a couple things before we start. One thing is that in setting this up, went through and actually rigged the head just a little bit so that I could pose it, right? For the love of God, don't do renders of your beautiful sculpture, character designs that are completely symmetrical. As I say to my students, in an intro poetry class, I had a professor say, you cannot use the word soul, right? Your soul is not breaking or dark or clouded or anything. You just can't use the word soul anymore in a poetry class and have people take you serious, right? Same thing in 3D. No more T-poses, no more symmetry. If you're going to show us your cool things, make sure that you do it so that the symmetry is broken, even just a little bit, right? So I did something with the ears so that I could hit this little bookmark view. They're just slightly different than each other, and I tweaked the head a little bit and twisted it. It's not perfect. If this weren't a tutorial, I'd want to do more, but at least break it a little bit. Little minimal effort goes a long way. Okay, rule number 2, this drives me crazy. Believe it or not, I see some students set up and render what their character looks like without an eyeball, right? I don't know why. Maybe they just haven't gotten around to modeling the eye. Go find one online, make a little quick one. I have one that I just simply modeled. I didn't even do any texturing, but it looks creepy if it does not have eyes, right? So please make sure you do that. Okay, so we have this set up. So let's go into the material. I created just a simple one to start. Don't freak out here, Maya, right? So I've got something called tutorial skin. It's just a base setup. So the first thing let's do is put the normal map onto this object. So how do we do that? Now, in Maya with Renderman, we can put a bump map or a normal map in lots of different places. We could put it into the advanced. We can put a bump here to deal with the primary specularity. If that's what we're doing, we could do it on the rough specular, or we can kind of do it across everything. And that's what I'm going to do here, right? So we're doing a bump map, and it's going to be a normal map. So I'll go ahead and click this here. And we're not going to use any of the Maya nodes. What we want is Renderman's patterns. And we can scroll down and find it if we want to work alphabetically through that. Or we could just type the word. Or if you can type, I can't type today. So you can choose normal map, right? And so it goes in there. And we need to give it the file that we're going to use. So I'll go find that. And there's that little normal map that I had. And we'll just say open that. And it puts it in there. All right, so a couple things. That's really all you have to do for starters. The one thing, and I only know this from, again, looking online, and let me say this. I started by putting this in here and like, why does it look weird? It doesn't look right in my normal map. So just a little investigation. Invert bump and flip Y is incorrect. And it has to do with how it's looking at the color and which direction that it's facing. So that's part one. Hopefully that's looking fine. We'll do a little render here and we'll look at problem number 2. So fire in the hole. Okay, and again, this is just the standard shader, right? And it's put in there, and I have the normal map cranked to 1. So the normal map is just changing the surface a little bit, right? It's not really, you know, displacing it. It's not displacing it, but it's giving it shading features. So if I look as this rendering here, it's being a little slow while I got the screen capture going, but you can see how it's working a little bit here, and I can see some of the detail. But I always find, whether it's bump map or bump scale using normal maps, the default of 1 is always too much. It's like trying to fake it and you put it to 100% and it's just a way of saying, yes, I'm faking it, right? So you might want to just dial that back just a little bit. The other thing too is our material isn't really reflective at all, even with the rough specularity. Except it's the reflections that help us see these little tiny details. Just think of the way we look at skin and we see the little, like the oiliness that we see on our skin and how it works across that, the texture of the skin. That's what shows off that surface value. So, so let's turn this down. Let's just try to 0.8 for now. That's gonna be a little bit better. And let's also go back to the material and let's close down the diffuse for a second. And let's at least go to the rough specular, and I guess I should have done an IPR here. We'll fire that again. Let's at least give it a little bit of some rough specular in that, a little bit of the face color and a little bit of that edge color. That will help us get a little bit of the way there. I don't see those little black lines that I saw as much, maybe just a little bit here. Just a little bit back there. So maybe we tone it down a little bit from 0.8, right? But just the whole idea with the normal map when you're using it with Renderman or something like that is to augment what you're going to do with the displacement map. If you're putting in a game engine, that's a different thing, right? But here we're just trying to add some of the finer details to go along with what we're going to do with the displacement map. So we don't have to so finely carve it up. All right, so that's a decent start. We don't have time. And then let's go ahead and we'll get out of that. Right, so already, so this was the base. This was too much normal map, better normal map, and I also like what's happening here on that lip a little bit, with a little bit of that reflection. And if we let this render for a little bit, that would really resolve itself a little bit better. So let's minimize that for a second. Let's go back and let's just put that 0.7. In fact, actually, let's do 0.5 for now. Okay, so that's the first thing. So the next part of this would be, what about the displacement map? So we have the material itself, the Pixar surface material. There's no displacement anywhere, because the displacement sits on the shading group, right? So this automatically gets created for you anytime you create a material, and the displacement material sits inside of here, right? So we're just going to go ahead and click that little connection, and it asks us where, oops, let's turn we don't want to look for normal, right? So where are we going to get the displacements from? So here it just says displacement, and it's the only one there, the Pixar displacement node. So we'll just go ahead and create that. And because it doesn't know exactly what we're doing, it connected both to the existing displacement material I'm sorry, the existing displacement or the existing shading group, this one here, but also gave us another one. So let's just go ahead and delete that. We don't need it. Okay. So now how do we ramp this all up together? Right? So we have a gain, so this is kind of like the multiplier. We have the old school scalar displacement, which we're not going to use. And then we have the vector displacement. And it has 3 inputs because it has color information that it's going to use. So let's click this. And it's going to ask us to create another connection. And instead of displacement, we want the displacement patterns. And here we're just going to choose the Pixar displacement transform. Okay. And inside of this, you can see scalar, vector displacement with the height that we want, kind of full strength, both the height and the depth. We can also, here, the displacement type, so instead of scalar, it basically says, tells you all you need to know about the current state of production digital sculpting. You have generic, Mudbox, and ZBrush. So we're going to choose ZBrush. And it automatically selects tangent for us, and we need to ramp in whatever that image is going to be that's inside of there. So inside of that, let's just go to Pixar's patterns, and we'll scroll down and just get a texture, if I'm doing that right. And inside of that, we're going to put the image that we want. So there it is. This is a pretty big file. It's EXR, it's crazy color information. We'll put that in there. Let's see, gain of 1. It's into the vector, comes into that. I think we have everything right. So let's just close this for a second and let's go back and fire up a render and see if what we got. All right, let's let this go for a second. All right, so we're starting to get displacements on this. Let's see if I popped back to the other one. You can see like where the ear inflates. You can see how these wrinkles start to do some things. This becomes more defined in those details, stuff around the nose as well. But we also are getting this tear, right? So why is that happening? Well, if we select this object, so when I was using the UV master, I'm not sure if it was just the default or UV master or the fact that I had originally built this with Z-spheres a long time ago. And so it had groups, and so it saw this as a separate group and ripped it out from each other. But I left it there knowing I wanted to see how it would deal with seams. And obviously we have one here, and this is problematic. So this is, I said before, the most important part. This is the other most important part of this tutorial. All right, so we'll hit escape there. With this object selected, if we go to its shape node, right? So not the transform node for it. I should have changed the name here, but so this the shape node for this object. If I go up to attributes in Renderman, I can add attributes to it. So if I just click on Subdivision Scheme, it will add the scheme type to this. And in the Renderman documentation, it suggests that you go ahead and do that. If I render here, I don't really think we're going to see any difference because I think this is already embedded as a default within Maya, and it certainly didn't fix the seam there, right? But just in case, I mean, it's in their documentation. You can go ahead and add that there, right? It's the same thing. It didn't change. So if you want to do that, if you're having some problems, that's the first place to start. And maybe it helps with the next part. This is the only thing I don't know for sure. So we need to fix that seam right there. So we're going to go back up to attributes, and instead of these existing ones that are kind of common that we could tell, hey, go ahead and add this subdivision scheme. We're going to go to Manage Attributes and go down into the netherworld of Renderman. And you hear all these attributes that we can add to objects that are just kind of hidden here. So the first one we want that's going to fix our scene is, and what's nice here is if you click on this, it tells you what something is doing, right? So if I click on Dice Watertight, stitches grids to prevent pinholes in geometry. There's another one where we could affect the distance as it sits in there, but I'm just going to do watertight and click add. Right? And so you see it adds it to the object. I'm just going to turn that on. I'm going to close that for now, and let's go ahead and render. All right, so our geometry looks much better. We don't have a rip in it. So it knows that for the object, it's trying to hold it together, right? So it's cutting it up in such a way that it's holding those seams together, right? It's keeping it watertight. So that fixed our seam, yay! Let's go back to the, the last thing that we can add here is if we go back up to Attributes, Renderman, and Manage Attributes again. Oh boy, what's that other one named? Micropolygon length. Values from 5 to 100 allow for faster renders, while the value of 1 is high quality and slower. I like high quality and slower. It's the way I roll. So the default is 5. Now, I haven't looked specifically at their documentation, but Moto had settings for this. So this would be if any given length is longer than so many pixels and it needs to divide based on the displacement map that's on it, then go ahead and do that. So this is just a refinement scale. So we can leave it at 5. We could turn it up if we want quick displacement maps, or we can turn it down to 1 if we're going for the total high quality. So I like high quality, we can turn it to 1. The other thing we're going to do here is go back to our geometry. Pains me that I've been doing it, the renders without the eye, right? This just looks silly to me. So I'm going to turn on this piece of geometry that I modeled in here. And all I did, let's see if I hide that. You can see I modeled a sphere, worked from the pole and kind of set in the iris, and then extruded down in to give us the geometry, I guess, that will give us some of that shading, right? Let's turn the... And then I also, very important, I put a cornea on top of it so I can actually get a highlight on top of that. I also, for that one, I guess here's another thing to mention here in the material attributes. For that, I created just a glass, and I made the refraction and the gain 1. So it's totally glass-like. It has a refractive index. Make sure that you turn on thin for something like this, and I turned the gain to 0. Turning that gain to 0 is kind of important, right? Because you can see if it's on 1, it just will be solid. So we want to turn that off so we can just deal with the glass parameters. Right. So we're almost there. Let's go back to our material for this one. I'm going to do one other thing here. So for tutorial skin, we already turned up the rough specular. I'm going to turn on the primary specular, just like this scocious, tiniest little amount. And I'm going to rough it up just a little bit more. So if I click on that color, I'm going to make this like 0.002 or 0.003. Let's try that. Tiny little amount, and let's make this one something like 0.05. And fire in the hole. All right, so I have an eye. It's now looking at me, right? That's important. We want to read and have connections across with the character, right? If we saw someone that doesn't have an eye, it would, we would take notice of that. So let's make sure that we always put an eye in our renders. Again, my own little pet peeve. Break symmetry, make sure it has an eye. You can see the renders resolving pretty good. I can still see just a little bit of an error from that normal map, but I think that's fine. And that specular, the primary highlight, that's this right here, that's that right there, that's this one here. It's these little things that are helping show off the surface a little bit more. Okay, now maybe that gets a little too wet, maybe looks a little too slick. Fun, be gentle with it, but really need to think about that. How that's affecting the surface, because it's going to show off these details that were not there in some of these earlier versions, right? Right? Dead to us, and you can see that little highlight pop up now. Again, I had that really, really low. It was 0.002 for the face color and 0.05, I think, for the edge color. But it made a difference. You can see it wasn't there before. Right? So it's helping with those surface details. Okay, so I guess the last thing we could do, we have the gain at 1. Let's go ahead and hit escape one more time. And this time I'll do the, let's go back actually to, yeah, I guess we want to do this here. So let's put the gain. Let's go ahead and choose the Renderman texture. And you can use a Maya. In fact, let's just go ahead and do that. I guess you can use Maya file textures if you want. So let's just do that. And we'll go to source images. And I think this was the other map that I did. And let's go to the hypershade. Let's take a look. And of course, Maya's freaking out. We'll see if it crashes right in the middle here. That would be awesome. Okay, it's in there. Come back to us, Maya. Okay, so there's our tutorial skin, and we put that cavity map in there, and the out alpha, or I could ramp, I guess, the RGB, but the alpha is seen as that that channel. So if you wanted to, you could just put it in like that. It doesn't matter. Okay, it's still going to sit there, but let's go ahead and let's put this away for a second. Go ahead and do another render. So that's controlling our gain for that diffuse. Right. So you can see it's getting a little crazy here with that black map that's in there. It's the way it's showing off the little indentations, right? So, you're like, oh my God, what did he do to that? Well, we can tone that down, right? I'm just trying to get something that's going to show off some of this. And I would certainly take something like this into Photoshop. And like, I really don't want the ones down here for this cavity map, but it is nice up here in these wrinkles. So how would I modulate that? That's the last thing I wanted to show. Let's put that there. So let's go to the Pixar pattern. And Maya has the same thing here. What we're going to do is remap. Okay, so we're going to use this remap node, and we'll just go ahead and put the color into this. We'll take that one out of there. So this now says, okay, here's the color that's going to come in. And then if I click on this a couple times, let's just take the R and put that back into the gain. And I'm going to pause this just for a second. Okay, sorry, I had to pause in the middle of that. I had a phone call. So, where were we? Oh yes, so we created this little remap node, and we put the color into it. Okay, right, the RGB. And so this is the input for it. We could change that range, and then the output. I don't want it to be black, right? So let's maybe make it that. And output max, I'm going to just tone that down a little bit. So we're just putting it in a slight range. I don't know, let's try that. So we're just, and we can cheat this one way or the other as far as the contrast. You can see we're just the bias, can ramp one way or the other. Put that back in the middle. So it's kind of like a levels adjustment, right? So let's go ahead and try that again. So before we had that crazy, right? Right, so still too intense. Clearly still too intense, but you can see how it's helping with the shading and that shadowing kind of down in those depressions. So let's fire this up as the IPR. Let's see if we can do a little refinement here. All right, so let's turn that up a little bit and let's bring that. Let's see what that does for a second. Right, so it's just getting down in those cavities, right? Making it a little bit darker. And we do these little things just to bring out the definition, right? You do that final 10% is where 100% of the image, the final quality goes, right? And that's what really makes it work. So I like that now. It's subtle. Let's try 0.65 and let's try 0.80. You know, we could turn on maybe some subsurface scatter or something like that, but this is doing some good stuff for us. Right? It's kind of showing off that surface. So I'll just let that render, of course. Oh, and the other thing, I wanted to turn that down. No, that's pretty good. We'll leave it there. So anyways, let's recap, and then I'm going to pull up this final image that I did here. So let's just close that. The main thing is, I guess I wanted to keep that up. Okay, so in addition to everything else, we made sure that there we go. So if I click on that shading group and ask it to show us the downstream connections, it shows us both the displacement shader, where we put an image into, put that in there, we put a Pixar displacement, and we ramped a node into the vector. We created a Pixar displacement transform, changed its type to ZBrush, and into the vector displacement we threw an image. I used a Pixar texture node. You could use a Maya if you want. We also can go over to, let's see, we put a normal into the global bump. We turn down the scale and invert bump and flip the Y. That's how it's reading the up vector for the color. Again, just everyone has their own little color set and what works. And just to make things a little bit different, we used the Maya texture node and put that into Remap so that we could change where the lightness and darkness was. Okay. Again, just like a levels adjustment, and we ended up with that image. The other thing, very important, for the object itself with its shape node, is that we added some, where did those go? There we go. We added the Renderman nodes, just the basics, but this fixed our problem, right? The dice, watertight, and then we turned the micro poly length to 1 so we get our best detail out of that. Okay, so the last part of this is what you do after you render and taking it into Photoshop and doing just a little bit of color work, a little color correction. So this is the final render here. Now that I've generated the new cavity map, you can see here it was just not enough, right? It was good here, I like that, but it needed to be kind of a broader color. We still see those details. We get little sense of that texture from the normal map without it being overwhelming. It's just breaking up the surface in a soft way. Wow, 35 minutes total. Lots of things covered. Hopefully that is helpful. Happy rendering.